Okay, so we've started talking about rational expressions and we've learned how to simplify them. So now we're going to go through kind of just like we did with polynomials, and we're going to learn how to add, subtract, multiply, and divide them. Um, this time, so with polynomials, we started with adding and subtracting because that's easier than multiplying them because remember with adding and subtracting, we just combined like terms, and then with multiplying, we used box method most of the time. And then with division, we either use synthetic or long division. So that was how we did it with polynomials. So with rational expressions, it's actually easier to multiply and divide them than it is to add and subtract them, just like with fractions. Um, you probably didn't struggle at all when you learned how to multiply fractions and divide them, but you probably struggled a little bit with adding and subtracting them. And so that's probably how it's going to be with rational expressions as well. So we'll start with multiplying, and this shouldn't be anything terribly difficult, but I do want to start with an example with just a fraction just to show you kind of the steps. So let's say we want to multiply the fraction, let's go 8 over 10 times 6 over 3. I don't know, just making this up. So if we wanted to multiply these, we could go ahead and just straight up multiply, but it's easier if we simplify each fraction first. So that's why the first step is factor each numerator and denominator. So we want to take 8/10 and simplify that. We could probably do that quickly in our head, but just to show the steps, we could say that 8 is 2 times 4, and we could say that 10 is 2 times 5, and we still got our multiplication. And we could do 6 and 3 the same way. We could do 6 times, or sorry, not 6, apologize. Oops, that shows what we're about to get to. Okay, so we could do 6 as 3 times 2, and 3 is just 3 times 1. Okay, we can keep going. So here our 2's cancel. We're left with 4 over 5 times. Here our 3's cancel. And we're left with 2 over 1, which is just 2, but we'll write it as 2 over 1. And then we just multiply across. So we multiply 4 times 2 is 8. We multiply 5 times 1 is 5. And that's our final answer. So remember, we could have come here and just multiplied straight across. 8 times 6 is 8, 16, 24, 32, 40, 48. Sorry, I did that for those of you who don't remember your multiplication tables. And 10 times 3 is 30. And that was right here. And then we would have to simplify this fraction, which is a little more difficult to simplify, right? So I guess we know they're both divisible by 6, right? So 48 is 6 times 8, and 30 is 6 times 5. Sorry, it took me a second to do that, not sure why. And then our 6's would cancel, and we're left with 8/5. Same answer. So that's just how to multiply fractions. And we did the same thing, right? So step 1, we factored each numerator and denominator. That's what we did from here to here. That was step 1. And then we multiplied the numerators and the denominators. It was step 2. We did that over here. We simplified. So it's a little different. It's not quite the exact same steps, and I'll show you the exact steps here when we do an actual rational expressions. But this is the main, it's the template for how we're going to do this. This is how we multiply fractions. So now let's go down to actually multiplying rational expressions. So I'm actually going to bring down the steps, or I'm going to try to. Okay. Zoom out just a tad, give myself a little more room to work. Okay. So the problem tells us to multiply the rational expressions and show the product in simplest form. So we're just going to multiply, the product is our answer, and we just want to make sure that that answer is in simplest form. So our first step, as it says here, step 1, factor each numerator and denominator. So we want to take each numerator and each denominator. So there's 4 things here that we're factoring. We got 2 numerators, 1, 2, 2 numerators, and 2 denominators. Okay, so let's start with the first numerator, x squared plus 4x minus 5, and let's factor it. So we're looking for something that, I'll just write it, x squared plus 4x minus 5. We're looking for something that adds to be 4 and multiplies to be negative 5. So our only options are negative 1 plus negative 4. Wait, that's not negative 4. Apologize. Negative 1 and positive 5. And then negative 1 times 5 is also negative 5. So negative 1, positive 5. Okay, so that factored is x minus 1 times x plus 5. That's our first numerator. All right, so now we can look at 3x plus 18, which is our first denominator, and factor it. We could pull out a 3, and it becomes x plus 6, right? 3x divided by 3 is x, and 18 divided by 3 is 6. So that becomes 3 times x plus 6. Then we still have our multiplication here. 2x minus 1, we can't factor that. There's no GCF we can pull out. There's nothing we can do with that. So it's just going to stay 2x minus 1. And then x plus 5. Sorry, my screen's kind of freaking out here. Maybe my computer's overheating. I don't know. X plus 5, again, nothing we can do. We can't factor that. We can't do anything with it. So it'll just stay x plus 5. Okay, so now multiplication is actually really easy once we do that first step. Because all multiplication is pretending that this is one big line and that everything's in parentheses. Because that's all we're doing. We're just multiplying everything, right? So it's x minus 1 times x plus 5 times 2x minus 1 on the top, and 3 times x plus 6 times x plus 5 on the bottom. So it's just, again, multiplication is just pretending that this is one big line. Okay, so now we just cancel out. So that actually took care of multiplying the numerators and multiplying the denominators just by pretending that's one big line. That's steps 2 and 3, really simple. And then step 4 is just to simplify, cancel out anything we can. So the only thing I see that we can cancel out here are these x plus 5s. It's the only thing that goes away. So on the top, we're left with x minus 1 and 2x minus 1. And on the bottom, we're left with 3 times x plus 6. And there's nothing we can do to simplify that any further. So we've simplified, and that's our final answer. And this one didn't say to name any excluded values. But if it did, we would just set both denominators equal to 0. So we'd set 3x plus 18 equal to 0 and solve, and we'd set x plus 5 equal to 0 and solve. So hopefully that makes sense. And the way that relates to these fractions that we did, with that just pretending it was one big line. So we could have done that here, right? This would have just been one big line, and 4 would have been parentheses, 2 would have been parentheses, which is multiplication. So it's the same thing if you didn't recognize that step. So hopefully that kind of is a good introduction to how to multiply rational expressions. And so here's what I want you guys to do. Sorry, give me just a second. Kind of winging this as I go. I want you to do a problem, one problem for me, and that will be your assignment. So I want you to try the following problem. So here's your assignment. Multiply and put in simplest form. Here's your problem. Okay. X squared plus 11x plus 30 divided by x squared plus 5x plus 6 multiplied by x squared plus 7x plus 12 divided by x squared plus 8x plus 16. So that's your problem. And I want you to follow the steps. So factor everything, multiply, cancel out what cancels out, and then put your answer in simplest form. Just do that and take a picture of your notes. You'll upload it. I'll put an assignment on Google Classroom, but that will be your assignment to do this one on your own. All trinomials. So yeah, that's your assignment for today.